This video is part of the Commercial Building Electrical Design series. We've been talking about power distribution design, and the videos or lectures up to this point, we've been looking at different aspects and components used in power distribution design. So this video, we want to try to take all those and put them together and see what it looks like when we create an overall power plan. So to do that, we want to look at some real life electrical design. So this is a set of electrical plans from a hotel. This is new construction, so everything here would be new. And let's look at how these things come together. So the first thing that we want to do is look at the legend. And so this will usually be on the first page of the set of electrical plans. So this will be a subset of the overall plans that the contractor has. So we can pull out the E sheets. And usually the very first sheet, or should be, the legend and some general notes. And so we want to look at the legend first a little more closely and see what we can find that might pertain to power. Now we're going to see a lot of other different things like lighting and communication stuff. We're going to go past that for now. We're going to come back to that when we look at those in more depth in this series. But right now we want to just look at power. So the first thing we see are power panels. And so you can see that we designate a difference between a 208 and a 480 volt panel. The 480s are hatched, the 208 120 panel, 240 panels are solid in color. So we should expect to see that on the plans. You may see some stuff about conduit turn up and stuff like that, but not typically. You will probably see different types of junction boxes. So here you can see this would be a floor box. This would be a wall-mounted box, and then this would be a box that's in the ceiling, and we can even have some designators if it's for a projector or a motorized screen, things of that nature. This symbol right here is pretty important, the triangle inside of a circle. So this is a special equipment connection, and so like if mechanical has some equipment that needs power or plumbing or some other discipline, we'll put this symbol and then we'll put a tag next to it. And then that tag is what we'll use on the equipment connection schedule to see what needs to happen there from the electrical standpoint of how to make connection to that equipment. So we'll look at the equipment schedule and we'll see some of these tags on the plans. Other things you might see is a transformer. If it's a 480 volt service, we'll be stepping that down with transformers. You might see an enclosed circuit breaker. Other things related to power that we might see, let's see, let's come by this. So here, if we have any cable tray, this is what that would look like. If we show conduit runs, which we typically don't, but you might see some on some plans, it's just the lines where solid lines concealed, dashed lines underground. If we have plan notes, of course, it would be the hexagon. More importantly, though, we need to get to the outlets. So if we have, this would be our general purpose 120 volt 20 amp outlet, and you can see it's mounted at 18 inches, which is what you should hopefully be used to seeing in your house or in a place of business, as we put those outlets up at about 100 at 18 inches. And then if it's filled in, it's the same device, but here you see it's mounted at 46 or above a countertop if there's a countertop, so we call that counter height. If it doesn't have the little prong things coming out there, then that indicates that it should be in the ceiling. If one side's filled in, then that means part of it would be switched if you wanted to like plug a lamp into that. And before I go further, let me say that there is no overall universal standard for these. So these are just the symbols that I typically use, but you'll see differences when you look at plans. That's why you need to look at your legend first, because every engineer could have slightly different way they indicate these different types of receptacles. So like for instance here, this would indicate 2, or some might call a quad outlet. Some other plans you might see that it has double hatching going the other direction, so it looks kind of like a tic-tac-toe on top of it. Some people signify the quad that way. And then we can put little tags on them, or subscripts to indicate different things. So like if there's a GF next to them, that would indicate that it's a ground fault type. If there's an IG, it's an isolated ground. If there's a weatherproof, then it's going to have a weatherproof cover and a ground fault receptacle. So you can see we can designate different types of receptacles and with these different subscripts. If we have a floor-mounted receptacle in a floor box, you typically have a box around it. On the riser diagram, we would show a panel like this, or it looks like you're looking at it. When it's hanging on the wall, it might have a transfer switch if we want to transfer between two different power sources. And I think that might be all we want to look at this time. So these are some things we can look for as we go through these plans. So let's start to thumb through these pretty quickly and just point out some highlights from a power distribution design standpoint. That's the fixture schedule. We'll come back to that. Here's our site plan. So most electrical plans will have an electrical site plan. So you can see the hotel outline is here. We have a parking lot. If we zoom in over here, we show the utility transformer location. So as we've talked about in earlier videos, this is where we kind of take over from the utility company. They'll run everything up to this point. It steps it down to our voltage that will run throughout the building, and so we pick it up from here. This particular project, we also had an emergency generator as an alternate that they could connect, and we'll show how that would be connected in on the riser diagram. And while we're not talking about lighting, we can go ahead and talk about that we have to power the lighting, and so these would be circuit lines showing how these light fixtures, these are pole fixtures, are connected, and then this is a home run signal showing that we run it to this location, then we run this back to panel 1S1, it'll be circuit number 4. And because these are such long runs and we are a little bit worried about voltage drop, we upsize the conductors. Normally we'd run number 12, which we talked about in the conductors lecture. In this case, we'd want to run number 8. And so again, in the conduit section, we hopefully by now would realize that's probably going to require a larger conduit. So we specify here a number 1. So we say in the specs and the notes that everything should be a minimum number 12 with like 1/2 inch or 3/4 inch conduit. But if we know it's going to be larger, we need to go ahead and call that out, and we can do that with the leader line here. Here's another instance of that, some more lighting, and we use an additional circuit for that. So these are the types of things you'd probably see, or you can expect to see on an electrical site plan. The site lighting, and then how the service is coming into the building, and oftentimes too we might show the location of the main switchboard. You don't have to, but you might see that as well. And then also down here at the very bottom, they're going to have a lighted sign, so we run a connection down to that so they can have power for their lighted sign. So the E1 sheets in this particular project are the lighting sheets, so I don't want to spend a lot of time on these. We'll come back to these when we talk about lighting. But we do just need to note that these all have to be powered. So on these sheets, you'll see there's a circuit tag next to each light fixture, and this says what circuit it'll be connected to. So the first 1L5 in this case is panel 1L5, and it's circuit position number 6. So all these can lights here would be connected that way. You might also see some circuit lines shown. Sometimes just for convenience that's done. Other times to show how things are switched. We'll show those circuit lines on the lighting plans. But from a power standpoint, that's really all we want to look at on these sheets. So you can see there's multiple floors in this hotel, and so we'll just we'll thumb through these, just knowing that the circuiting is shown from a power standpoint, but that's all we're looking at from power. So now we get to the E2 sheets, and this is where the power design actually takes place, and you can see this is first floor power. There's also communications on these sheets. Not going to talk about that at this time. We just mainly want to look at power. So with that in mind, remember our pad mount transformer was up here, and that was the reason for that is because our main electrical room is here. And so we usually want to try to put that pad mount as close as possible to the main electrical room. And the reason for that is that secondary run, our contractor / owner is responsible for that. So the shorter the run, the less money we have to spend to do that. So we usually try to locate it as close as possible. So with that in mind, we look at take a little closer look at the main electrical room. You can see we have our main switchboard, and then we have 3 panels in here. We don't have to worry about the double exit we talked about when we talked about panels, because this switchboard will not be wide enough. It doesn't meet that minimum criteria. So we should be fine with just one door. I did make the recommendation that it swing out, but it doesn't have to. I think that's just a good design practice. And here we have our telephone backboard, so you can see we have an outlet on the wall for that, and then an outlet over here on the wall. And these are up at 46-inch height. We usually put them up high in the electrical rooms because they're usually plugging in hand tools if they're working in there. It's a little more convenient for them. And you can see they have the circuit tags just as the light fixture did. So this would be from panel 1E1, circuit position 32. And you'll notice that we do have a naming convention on this set of drawings, and so the E indicates emergency, so it is connected to the generator. So if you lose main power, this outlet would still have power once the transfer switch switches over and the generator starts. Whereas this outlet here, the 1L5, that would not. And so the first digit in the panel name is the floor that it's on, so these are all on the first floor. The L usually indicates lighting panel, or lower or level panel. You can run outlets out of there as well. S was for site, so all the site power comes from this S panel. But your naming conventions can be whatever you want, but these are just what we picked on this project. And so as we kind of step through the project here, we'll see all these outlet locations. And so, we need to talk about that a little bit. There's really no code requirement per se of spacing for outlets on commercial jobs. On residential projects, there are. There's what's known as the 12-foot rule, or some people call it the 6-foot rule. And that is that there must be an outlet every 12 feet. The reason for that is most household lamps and appliances have a 6-foot cord. So that's why some people call it 6-foot rule, some 12-foot rule. So if you have them every 12 feet, no matter where you put whatever it is you're plugging in, you should be able to reach an outlet location. But that rule doesn't apply to commercial work, only residential areas, which we will have on this project. But in the commercial areas, there's no real rule for spacing, so we just kind of use common sense and experience. So like in an office here, you're probably going to want an outlet, at least one outlet on each wall. And we'll try to be cognizant of where the furniture location is, or desk. So we put one for the desk. Looking a little closer here at the back office, they have a work counter here. So we've got several outlets you see, and we've got some below the counter and some above the counter. Same thing at the registration desk, some up high above the counter, some below. I think they have a printer down below, but they might have other stuff, computer and whatnot up top they want to plug in. So again, just trying to use common sense where to place these outlets. You might even think about it if you were in the space and you were a user there, how would you utilize that? Here you can see they have TVs wall mounted here, and so it was a little busy, a little cramped trying to get everything in there. So we used leader lines and just said these all have to be located on this wall. And you can see these outlets are actually isolated ground outlets. We talked about that, and we'll see how that works on the riser diagram in a minute. And then here we have some connections for some outdoor equipment and lighting, and so we put weatherproof junction boxes out here and running all the power to that. And here's another electrical room that's on this floor. It's actually the only other one. This is a combination electrical and mechanical room, which is pretty common. And so they've got some major mechanical equipment in here, and then they leave us space over on this wall. We can put electrical panels, and that's okay as long as they maintain the clearances. To save space a little bit, they'll do that type of thing. And so as we continue walking through, we'll see we got an ice maker here, and we've put a GFI outlet there. And usually anytime there's any type of equipment that we know is going to be plugged in, we usually make that ground fault, because then that extends to the grounding of the case, or the outer part of the equipment. So in order to protect the users, we want that ground fault. So if it shorts to the casing by some defect, it'll protect the user and should trip the unit. Here we have a little conference room, and so you can see we wanted some floor boxes underneath where the potential conference table would be. And we've actually got a power outlet, but then we also have junction boxes here that run up to a junction box in this closet in case they wanted some audio equipment or some type of video controls, trying to give them some options there. Some things worth mentioning here. This is the elevator pit and the elevator room. And so you'll notice we put an outlet in the elevator room, and then we put an outlet in the elevator pit, and that's required by code. We have to have those in there. But another code requirement is these outlets can't be on a circuit with any other outlet. So you can see we've got panel 1L2, circuit 22 feeding all these, but you won't find anything outside of here on that same circuit. So elevator room and elevator pit have to be on a circuit by themselves, and again, that's a code requirement. We do have a pool here. We'll look at that on a different sheet, so I have that hatched out because I treat those separate because there's some special things you have to do for pools. One interesting thing here is a lot of these rooms are typical, so they're exactly the same. So I just showed how we wire it up in one drawing on a later sheet and just say that we're going to need 4 circuits per each room, and so I just assign the circuits here and then show them how to hook up the mechanical unit, which is the wall unit for the air conditioning in the hotel rooms. So again, these are pretty typical power plans and the way things are done. And of course, it wouldn't fit on the sheet, so we had to slice it up with a matching at the match line. From a power standpoint, you're seeing a lot of the components we worked with. You look down here, like they have a little wall heater in this stairway. And so this is that special equipment mark, so it's electric heat 2 is what this stands for, and we'll look at that when we get to the equipment connection schedule later in the plan set. So let's look at this as a whole again. Again, we had our electrical rooms. We have one here and one here. This one's pretty good location. We're going to be able to stack on top of that one, but not so with the other one. And if we can stack them, that's usually what we like to do. And then another rule of thumb is in sizing these. So electrical rooms, general electrical rooms, I usually try to ask for at least a minimum of 6 foot by 9 foot, which usually gives me plenty of room for whatever panels I need to put in there, maybe even a transformer. For the main electrical room, I usually ask for 12 by 10. And I don't always get these requests, but these are, when we're doing space planning, that's what I usually initially ask for, and I usually work around that. So, again, moving down, you can see some more stuff here. There's air handling units that are in the ceiling, so we have connections for those. We have floor boxes out here in the floor. We have a TV above this fireplace, so we've got an outlet located up there above that. So, again, just common sense placing outlets, and then we circuit them up and see how it all works together. So moving on from that, we go up to the second floor, and so whereas on the first floor we had the back office, the front counter, some public space, we get up on the upper floors and it's mainly just guest rooms, and that's all there is. So not as much to show up here. We will look at the electrical room. Here's one of the electrical rooms, again stacked on top of the main electrical room, so that's pretty convenient. We do have a washer and dryer here, so you see have a dryer special connection and then an outlet just for the washer, and then the circuits per room like we talked about before. They did give us another electrical room on each floor here in the middle, and that helps kind of with voltage drop because we didn't want to run our circuits the entire length. So this kind of gives us a medium point there. So we stuck 4 more panels in these middles. They're really storage closets, but we're using them for storage / electrical rooms, which is okay as long as they don't put stuff in front of it. The next sheet should be pretty much the same because it's identical to the second floor. So the third floor is the same, and then this fourth floor again, same thing going on here. So everything is pretty typical there. So now we come to the roof plan. And so again, we have other stuff going on the roof we're not going to talk about at this point, which is lightning protection and some other stuff, but we have quite a bit of mechanical equipment up here. So you see we have a lot of equipment connections, and so we put the special connection symbol, and we put the tag, and again we can coordinate that with the equipment schedule, which we'll look at here in just a little bit. Again, we had to cut it up to make it fit on the sheet. Um, and we do have outlets up here, and these outlets, the code says anything that has a motor, you have to have an outlet within 25 feet of it, I believe is what the code says. So that's where these outlets are strategically placed, just to make sure there's one within 25 feet of every one of these units. And that's, of course, in case they need to use power tools on those while they're working on them. Usually 25 or 30-foot extension cord is pretty standard for an electrician or a maintenance man. We also have some power connections up here for signage on the side of the building. And I think that's about all there is power-wise up here on the roof. So moving on, here are the typical guest rooms that I talked about earlier. So here you can see, if we had a king shower one, which that's how it'd be called out on the floor plans, this is the way it's laid out. So we have the outlet location. So in here, that 12-foot rule can apply. So we will put, a couple more outlets in here than maybe we normally would. We also make accommodations for coffee pots and microwaves if they have them. And we have our GFI outlet in the bathroom. We put outlets next to the beds where the end tables would be, and at this desk. And we also power the lighting and all that. And then what I show here is that should all run back to this junction box, and this is where we'll have the 4 circuits going to the panels that I talked about earlier, and where we assign 4 circuits per each one. So you can see for each room we do a separate layout and show how everything should be connected, and special notes for equipment that's in there, things of that nature. And again, more typical room layouts. So I talked about the swimming pool we do separate. So here's a shot of the pool, and it also includes the exercise room. So you can see we have floor boxes strategically placed for the equipment that needs power. We have wall outlets and TV outlets strategically placed. We've got outlets in the restroom. And then we have some outlets around the pool. Now, many pools will have a emergency shut-off requirement depending on what jurisdiction you're in. So we put a switch here with a shunt trip for the panel. So you can see here I have a note on the panel that feeds the pool. The main breaker is to be a shunt trip type, and it goes back to this button here. And so again, we usually have a cover over that where you have to lift the cover and then push the button so it wouldn't be accidentally hit. But that's in case someone gets caught up in the suction of the pool, or there's some other emergency and they need to kill the power. They can do that, and that would shunt trip this main, which would just kill all the power in this panel. As you can see, we do put some outlets around the pool, and then we run some power down here to the pool lights. And then there's pumps inside here, pool pumps, and that's all fed from this pool panel, 1P1 in the pool equipment room. As you can see, we have multiple different types of loads run from this panel. Most of it's non-continuous. That's what N is. So clothes dryers, they don't usually run for 3 hours. The fitness room, most people don't work out for 3 hours or more. And so we can consider that all non-continuous. We have some lighting and some general receptacles, and so that's what shows up down here in the load summary of each panel. You can see that, how it pans out. Also on this project, we have a small kitchen, where they prepare breakfast like most hotels do. So you can see we had a kitchen equipment consultant lay out the kitchen, and so then he sends me the equipment and the cut sheets, and I power them up. So for each of these, we have this panel, and we have a kitchen equipment connection schedule, and so you can see like this piece here is K050. I come down here to K050, and that's a freezer. This is all the information about the freezer, and it'll tell me what circuit it's connected to. It's 1K13, so come up here to 1K13, and there's my freezer. So you can see there's quite a bit of a kitchen equipment here. So if you look down in the load summary, we do get to take that largest diversity factor, 0.65. So all the total load was 19, a little over 19 kVA. But after we diversified, it's really a little over 12. So that really helped out as far as this, because you don't expect to run all these at the same time all the time. We do have a few other miscellaneous outlets and stuff like that on here, and there's the panel location here in the kitchen, and just all the equipment connections. So pretty typical little kitchen, small kitchen, what this would look like with between the equipment connection schedule and the panel itself. So this is the power riser diagram. This shows how the power is distributed throughout the building to all the main panels. And so you can see all the same tags here that we hopefully saw on the floor plans, 1L1, 1L2. You can see these are double panels, so we're utilizing feed-through lugs. So the service or the feeder comes into this panel, and then it's fed through the buses through feed-through lugs to this panel. So this really acts as one panel. It just gives us more breaker space location. Whereas in this case, you see there's a line between these two. That means there's a breaker inside of this one feeding this panel separately. This is a small lighting panel here. And it's our main switchboard, and then we go up to different floors and feeding all the different panel locations. So this gives you an indication how much feeder conduit you're going to be running throughout the building. We also have a transfer switch. So we have this generator that comes, and so this panel 1E1, it can either be fed from our main switchboard, which is normal power, or it can be fed through this feeder through the transfer switch from the generator. So it could be run on emergency power. And so you can see we put the elevators on that as well. International Building Code says buildings that are 4 floors or higher, the generator, at least one elevator has to be on generator power. So that's why we did that here. And you can see the main service coming in. And then we've stubbed out some spare conduits here. And then if you want to see what's connected between each panel, so like we want to go from panel MSB to 2L1, you can see we're going to run 4/aughts, one number 4 ground, and a 2.5-inch conduit. So that would be a 225 amp panel. And this is true for every connection you see on this sheet. You should be able to find it from and to points and identify what's run between those 2 points, what each line represents. So some people do it that way. Some people just write it straight right on here, or they'll use a leader line and call them out. There's different ways to do that. I found this way works pretty good. So again, this is your main power riser diagram, though, and what that might look like and how to read it. It's fire alarm, we'll come back to that. This is telecom riser, we'll come back to that. So then we'll have several pages of panel schedules, which is typical. And so like 1L1, you can see everything in that and the code schedules. And so this is, the 1L1 is feeding mainly guest rooms. And so remember, when we have a hotel motel lighting, the code says that lighting and receptacles can be diversified by this same factor. So we originally had 33 kVA fed out of this of hotel room load, but because of that diversity factor, we can knock it down by over half, and so we really only have to account for 15, a little over 15 kVA when we're sizing our panels and feeders. Looking at some other panel schedules, these are all guest rooms. Here we have just mechanical equipment, so you see we have HVAC loads and space heating. Come over here, we have non-continuous, we have receptacle loads, lighting loads. So again, just every kind, and we can look at every kind of load you can think of, and they're down here. You can see how they're handled in the load summary down here. And so again, we just have panel after panel, same thing, doing the calculations, adding up the loads, applying diversity factors, and 33rd floor panels, 4th floor panels. Then we get to the really interesting one. We come to our main switchboard. So that's over here. And so you can see we have all the breakers feeding all the panels from that riser diagram. This is where we tally up all the load in the building. So you can see here, as far as motel room, lighting, and general power, we have 372 kVA. we can apply that diversity factor now of 0.33, so that knocks it down by a third. So that's a pretty good diversity, and we're expecting to see every bit of that, if not more, because they don't book out every room every day, and even if they did, they wouldn't have all their loads on all the time at the same time. We have pretty good HVAC load, a little over 600 kVA in HVAC. Kitchen appliances, we already saw that. General lighting, almost 18 kVA, but we have to bump that up because that is continuous. We do have some other continuous loads that we have to account for, and then we have our miscellaneous non-continuous. The real interesting one here is the receptacle load, 19.4, but again, applying that diversity factor, you only have to take 3/4 of that. So when all said and done, we originally had a connected load of about 1,300 kVA, but we're just barely over 1,000 once we apply all our diversity factors. So if we convert that to amps at 122.08 and add a little bit for future capacity, we see that we should be okay with a 3,000 amp switchboard. So here's some other branch panels or site panel or lighting panel, mechanical, and then here's that emergency panel we talked about. It has the elevators fed off of it and some other life safety loads that we're allowed to run off of that. So, and then we also have a generator. We can see what the generator load is. If we have to have a fire pump, it would need to be on generator as well. So this is what's on the transfer switch, which is 1E1, and the fire pump. So you can see how much load that is and how we size that as well. So this is how we tally up all the loads and size our equipment. Here is our equipment connection schedule that we talked to. We saw the one for the kitchen and for the pool, but this is the one for the mechanical equipment and everything else. So again, we have like all the air handlers, condensing units, exhaust fans, elevator connections, fire pump, heat pumps, rooftop units, clothes washers and dryers. And again, everything we'd want to know about each of these pieces of equipment should be contained in here, from what circuit it's attached to what size pipe and wire we run to it, if it needs a disconnect and what kind. So a lot of information here, and once we just match that up with the tag, we should be able to figure out everything we need to know about each equipment connection. Finally, we do have some details. I've shown some of these already, but just wanted to touch on these. So our main service duct bank, we'll show how that comes into the building. So we run these underground PVC conduits, and we need to be sure and use these spacers when we're doing that if it's concrete encased, because when you pour the concrete, one thing that can happen is these conduits will start to float, and so they won't maintain their spacing. So it's pretty important to use those spacers. Here's our main grounding, which I think I've shown this detail before, but this one's a little different in that they want an isolated ground. So that means a totally separate ground for sensitive equipment, which we talked a little bit about. So you can see here's my main service ground connection and bonding and all that. We bond it to the neutral. But then this panel 1L5, they wanted an isolated ground. So I show that we run the neutral and the ground separate to this location. Then we put an additional ground bus with 3 more ground rods and connect that. So this ground is not the same as this ground, and you wouldn't be able to tell continuity between them. And so that's how that would be done. And then we've seen I think these other details pretty common. I think I've shown them before for spacing and how the meter and the pad mount transformer should be set up. These are lighting details, fire pump connections. We'll talk about that in a little more detail later. How we wire up our outlets. And so one thing that's important here that we're showing is, most of these outlets will have 2 connections here for if you want to have, for some reason, have a different neutral connection to one outlet to the other, but then they put this little strap across it. And so, what some people would do is they'd run the neutral down here and then connect it and run it onto the next outlet. And we want to make sure you don't do that, that you wire nut this here and use that to run to the next outlet and just, run this pigtail is what we call this to the power outlet here. We show how different types of methods to to strap and hang conduit and what's allowed with that. Um, these are telecommunication drawings, and then if we do go through a firewall, we are required to seal that to make sure that it maintains the firewall integrity. So this shows different ways to do that. So yeah, this is just a typical set of electrical plans. We're just hitting the highlights. We could go down deeper dive into some of this stuff, but for the scope of this course, a summary course, this is a pretty good overview of how that all works. So um, this is a good picture of an overall set of power plans and how it connects together.